Derivative Application Unit 2, Tangents and Normals. So here is a thinking problem. Question 11. The flight path of a spacecraft is represented by the parabola y equals to x square. If the engine is shut down at the point P, the spaceship will fly off along the tangent line at P. If the spaceship is moving from left to right, at what point should the engine be shut down in order for it to reach the point 47? So let me sketch this and then I'll explain you the problem, right? And then we'll try to solve it. So the parabola is y equals to x squared, which is kind of like this. That's our parabola. And we are moving from left to right, and point P is somewhere on this path, so that when you release from point P, the tangent line reaches 0.47. So let's say point P is somewhere here. So if you release, then you reach a point which is 47. So that is the point P for us, right? And let's say this point P is at x equals to a for the time being, correct? So let's read the problem once again and try to understand what we need to do. A flight path of the spacecraft is represented by the parabola y equals to x squared. So that's the parabola y equals to x squared. If engine is shut down at the point P, the spaceship will fly off along the tangent line at P. So that is the path of the spaceship shown in green, right? If the spaceship is moving from left to right, at present it's moving from left to right, right? So that is the movement. At what point should the engine be shut down in order for it to reach the point 47? So we want to reach 47, and we want to find what is that point at which engine should be shut off, so that the tangent from here reaches 47. That's kind of the problem here, right? Now, how to solve these kinds of questions? We don't know the point. So in most of the cases till now, we knew the point. We were trying to find tangent line at a given point on the curve. Here, we know where the line will go. We know a point on the tangent line, which is not on the path of the curve, but we need to find another point on the path. That's the whole issue. So if the x value on this path is a, what is y value? Y value should be a squared. So point P can be defined as a squared. Do you understand? Now, what is the slope between these 2 points? Between 47 and a squared. Let's call this point Q for the time being. Okay. So we say slope between P and Q is actually y2 minus y1 over x2 minus x1, where y2 is 7, right? So 7 minus y1 is a squared divided by 4 minus a. 4 minus a, okay? So that is the slope PQ. Now this slope is at point P for this curve. We can find slope at point P from the derivative of y equals to x squared also, right? So we have y equals to x squared and y dash will be 2x. Now at point P, slope y dash should be equals to 2a, right? Now, as we have already found, slope is, equation 1 shows slope at P, and equation 2 also indicates slope at P. Both these slopes should be equal, correct? So we can equate these two and then figure out what is the value of A, right? So let's do that part. So let's solve for A after equating both the slopes, because the tangent between P and Q and slope at P with the first derivative, right? So let's equate these two and calculate. So that means 2a equals to 7 minus a squared over 4 minus a. So we can cross multiply and find a, right? So we have 2a times 4 minus a equals to 7 minus a squared, and that is 2a is 8a minus 2a squared equals to 7 minus a squared. We can bring the terms together and then solve for a. So it's better, so let me just move on one more space to the right. So what do we get? So we bring this 2a to the right. So we get 2a square minus a square minus 8a, and there's 7 here, so plus 7 equals to 0. So that's what we get. Now that is a square minus 8a plus 7 equals to 0. That can be factored as 7 times 1 is 7, both negative, times a minus 1 equals to 0, right? So when you multiply minus 7 with 1 minus, you get 7, and sum is this, right? So the point A could be at x equals to a equals to 7, or at a equals to 1. So these are the two possible points, right? A equals to 7 and a equals to 1, at which the slope is going to match with the given slope, right? So from the given situation, since we need to move from left side to right side, it is obvious that a is equals to 1, right? So we'll take a as 1 and then solve our problem. So that means the relevant answer for us is a equals to 1. So a equals to 1 is really the point at which, if we shut off the engine, then the spaceship will move to point Q, right? Because it will have the same slope as desired by PQ, right? If a is 1, what is the value of y? That is a square. Then a square will also be 1, and therefore the point of interest for us is 1, 1, right? So that is the point of interest. So, and that is the answer for us. I hope you understand the whole concept, how we did this question. Important thing here is first to draw and understand. So that is the path which spacecraft is taking. It's moving from left to right. If the engine is shut off here, it will go tangentially, and we need to find that point so that it reaches point Q, which is at 4, 7. So that is the problem. Now we found tangent at P with two relations. One using PQ 2 points, 4, 7 and a square, which gives us y2 minus y1 divided by x2 minus x1 as the slope of the tangent line. And the second is by finding the first derivative. Y equals to x squared, first derivative is 2x, and the value of x is a. Equating the two, we could find what a is. So we took the relevant value of a and got the answer. So go through this video, try to understand. It's a very important question, and it's been seen or asked in the test papers so many different ways. Okay, thank you and all the best.